Today we are going to practice subtracting fractions and mixed numbers. Okay, so the first one we're going to do is 5/9 minus 1/9. So just like adding fractions, we want to make sure our denominator is the same number. That is just the easiest way to add and subtract fractions. So since our denominator, the bottom number, is both 9, then we are good to go. So we have 5/9 minus 1/9 is going to give us 4/9. We just go 5 minus 1 is 4. And then this is our answer. We can't reduce it or anything. It's good to go. Let's try one a little bit more tricky. 7/10 minus 3/10. Okay, same thing. Both of our fractions are in tenths, so we're going to keep the 10, and 7 minus 3 is 4. There's only one other thing we have to do. We have to reduce this 4/10. So just think for a minute, what number goes into both 4 and 10 evenly besides the number 1? These ones aren't too bad because both of these numbers are even. So we know that 2 goes into all even numbers. So I am just going to cut both of these in half. Half of 4 is 2, and half of 10 is 5. So our reduced answer is 2/5. Now these are the same value. This one is just the better answer because it's reduced. Okay? 7/9 minus 1/3. Okay, when we have different denominators, we don't like that. We want them to be the same denominators. So we're going to think, what is the smallest number that 9 and 3 go into? Or what is the number that both 9 and 3 go into evenly? So if you can't think of that, you could always multiply those numbers together. 9 times 3 is 27. So we know 9 goes into 27 3 times, and we know 3 goes into 27 9 times. So we could go that route. But what I'm going to do is I see that both of these numbers go into 9. 9 goes into 9 once, and 3 goes into 9 3 times. So this way, I just have to change one of my fractions instead of both of them because this one's already in ninths. Okay, so I'm just going to take this 1/3 and change that into ninths. So 3 times 3 is 9. 1 times 3 is 3. So instead of 1/3, I'm going to write 3/9. It's the same value, it's just a different denominator. Okay, now this has gotten a lot easier. I keep that 9 as my denominator, and 7 minus 3 is 4, and that is my answer. We can't reduce it or anything. 4/9. Okay, let's do 9/10 minus 3/4. Okay, same thing. Let's think of a number that both 10 and 4 go into. What about 20? We also could have multiplied these and used the number 40. We would just have a little more work to do at the end because we would have to reduce. But I'm going to go with 20 because I don't want to have to reduce. So we have 9/10 into 20ths, and we have 3/4 into 20ths. Okay, 10 times 2 is 20. 9 times 2 is 18. 4 times 5 is 20. 3 times 5 is 15. Okay, so I have 18/20 minus 15/20. So I keep my denominator, 20, and then I just do 18 minus 15, which is 3. 3/20, that's our answer. And that's actually the reduced answer in everything because there isn't a number besides 1 that goes into 3 and 20 evenly. Okay, let's do 2 more. These ones are going to have mixed numbers in them. 1 4/5 minus 2/3. Okay, think for a minute. What's the smallest number that both 5 and 3 go into? If you said 15, you are correct. We're going to change both of these fractions into 15ths. Okay, 5 times 3 is 15. 4 times 3 is 12. 3 times 5 is 15. 2 times 5 is 10. So I have 12 fifteenths minus 10 fifteenths. And I can't forget about this 1 that I had up here. It's actually 1 and 12 fifteenths minus 10 fifteenths. So I have enough fifteenths here to take away 10. So I don't even need to bother with that whole number. I'm just going to say 12 fifteenths minus 10 fifteenths would give me 2 fifteenths. And then 1 minus nothing is 1. So my final answer is 1 and 2 fifteenths. I can't reduce that 2 fifteenths. It is all good to go. Okay, we're going to do one last problem. 2 and 1/7 minus 1 and 7/8. Okay, so the first thing I'm going to do is, just like what I've been doing, find a common denominator. What is the smallest number that 7 and 8 both go into? 56. 56 is 7 times 8. 5, 6, 7, 8. Okay, so I'm going to change both of these into 56. 7 times 8 is 56. 1 times 8 is 8. 8 times 7 is 56. 7 times 7 is 49. Okay, so instead of 2 and 1/7 minus 1 and 7/8, I am going to have 2 and 8/56 minus 1 and 49/56. So this one is just a little bit different from our last problem because I want to take away 49/56 from 8/56, but we can't do that unless we go into the negatives. So I'm going to just rearrange some things so we don't have to go into the negatives. Instead of writing 2, I'm going to change this to 1, and I'm going to move one of my wholes over here and combine it with this 8 that's already there. So remember, our wholes in this scenario is going to be equivalent to 56, 56. And I'm going to add that to this. So I have enough to take away 49. So in my head, I'm going to think, what is 56 plus this other 8? And that is going to be 64. So you could always just add 8/56 out to the side, and 56 plus 8 is 64. So I'm going to change this to 1 and 64/56. So I have enough to take away that 49. Okay. Next stop. 1 minus 1 is going to give us nothing. So I know those are going to cancel out. So all I have to do is take away 49/56 from 64/56. If you can't think about that in your head, you can always come over here and do 64 minus 49. 9, 10, 11, 12, 13, 14, and 5 minus 4 is 1. So we are going to get 15/56. And then, like I said earlier, 1 minus 1 will cancel. So our final answer is 15/56. Okay, if you enjoyed that video, please click subscribe so you won't miss out on any other math videos from me.